Okay. Let me go ahead and share my screen and we can jump in. All right. Okay, so today we're going to look at parallelograms. More specifically, we're going to look at different theorems that have to go with parallelograms, specifically with their side lengths and their angles. So instead of triangles, we're going to go into parallelograms. The different words we're going to look at today, we're going to review what it means to bisect. Something new that we're going to look at is consecutive angles. Again, we're going to learn about parallelograms, and then we're going to do a little bit of a review of supplementary angles. Give me 1 second. All right, so let's just hop right in. So first thing, just a quick review. So we learned that whenever we have two parallel lines cut by a transversal, we get different types of angles. And so the ones that we get are corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. And so if you don't remember, corresponding angles are, for example, angles like 3 and 7, and they're corresponding because they are on the same part of, so they are on the same part of those parallel lines. So 3 and 7 would be an example. Another example would be 2 and 6. Another example would be 1 and 5. And another example would be 4 and 8. So those would be corresponding angles. And what we learned is that corresponding angles are congruent to each other. So 3 and 7 would have the same angle measure, 2 and 6, etc. So that'd be corresponding angles. We also learned about alternate interior angles. An example of that would be 4 and 5 and 3 and 6. Remember, the first criteria is they must be interior angles, so on the inside, and then they have to be on alternate sides of the transversal. And we know that these two angles are congruent. So 4 and 5 would have the same angle measure, and 3 and 6 would have the same angle measure. Next thing we looked at was alternate exterior, kind of the same thing as alternate interior, but these are on the outside. So an example of this is 1 and 8 and 2 and 7. So these are on the exterior, but they are also on alternate sides of that transversal R. And then lastly, we looked at same side interior angles, which are basically, first thing, they must be interior angles, so on the inside of those parallel lines. But instead of being on alternate sides, they're going to be on the same side. So 3 and 5 and 4 and 6. Okay? And then the one difference between these, the relationship is that they are supplementary. So if we added 3 and 5 together, we get 180 degrees. If we added 4 and 6 together, we would get 180 degrees, right? That's what we learned about supplementary angles. Supplementary angles equal to 180 degrees. All right? Okay, so now let's get into parallelograms. So the first thing we're going to look at is the parallelogram angle theorem. And this one's pretty straightforward. It just says that opposite angles in a parallelogram are congruent. Opposite meaning opposite sides of each other. So these two are opposite sides of each other, so they would be congruent to each other. And these two on opposite sides of each other, so they would be congruent to each other. So for example, if this was equal to 80 degrees, then this would be equal to 80 degrees. If this was equal to 100 degrees, then this would be equal to 100 degrees. So that's the parallelogram angle theorem. Basically, the opposites would be congruent to each other. Okay. Now we're going to look at the supplementary conservative angles theorem. So what are conservative angles? Let's first do that. Conservative angles are two angles that share a side. So two angles that share a side. Okay, So what do I mean by this? Well, I basically mean, let's say we have this side right here. The two angles that share those sides are C and D. Okay, same thing if I were to say, which angles share this side right here? Well, the answer would be F and E, and so on and so forth. So those are conservative angles. So conservative angles in a parallelogram are supplementary to each other. So what does that mean? Well, that means if you add those two angles together, they should equal 180 degrees. So for example, if I wanted to find the angle measure of C and say that I knew that D was equal to 70 degrees, well, I know that D and C, because they are conservative angles, they must be supplementary. So therefore, C is equal to 110 degrees. So that's what I just solved for. So basically, conservative angles are supplementary. And then the unique thing about this and about the angle or the theorem that we just looked at is we also know how to identify the measure of opposite angles, because opposite angles in a parallelogram are congruent. So if I wanted to find the measure of angle F, that would be 70. And if I wanted to find the measure of angle C or angle E, well, look at the opposite angle. That would be 110. And then if I want to see, okay, well, E and F are conservative angles, so they must equal to 180 degrees. Okay, well, if I add E and F together, they would still equal to 180 degrees. And so that's how we use these two different relationships together to solve for different angle measures. And so we're going to look at an example of this. So basically what we're going to do here is we're going to find the different angle measures, the missing angle measures, using the parallelogram angle theorem, and then the supplementary conservative angle theorem, okay? So we're looking for the measure of angle C, the measure of angle D, the measure of angle E, and the measure of angle F. Okay? Well, let's see. The one thing I'm told is that C is equal to 93, so I can put 93. Okay, so which one do I want to go through first? I'll go ahead and do the parallelogram angle theorem, which basically says opposite angles in a parallelogram are congruent. So I want to see what my opposite angle of the angle that I know is. It is E, and so that means that E would be equal to 93 degrees because those opposite angles have to be congruent. Okay? So do I have any other opposite angles? Yes, I do, but I don't necessarily know what those missing angles are. And so we're going to go ahead and figure them out. So now we're going to move on to the supplementary conservative angle theorem. Okay, so what does that tell me? Well, it tells me that these two angles, my conservative angles, are supplementary, so they're equal to 180 degrees. So that means that I can add C plus D and get 180 degrees. So C is 39. Minus 39. 93, sorry. So D is equal to 87. Okay, so now that I know D is equal to 87, I can put that here. And what do I know, or how can I go ahead and find F? Well, F is the opposite angle of D, which means it's congruent. So F would also be 87. So in using those two theorems, I was able to find the missing angle measure for all my different angles. Okay. Does anyone have any questions about how I found the missing angle measure for any of my angles? Any questions? Pretty straightforward, right? Okay. So we can also use those two angle theorems to find angles that look like this. So we're not necessarily given an exact value, but we're given, in this instance, P. So first thing we want to do, like we've always done before, is find out what P is. And so the way in this instance you can find out where P is you know that opposite angles are equal to each other, right? And so that means that I can put those two equations equal to each other. And I'm looking for P, so I'll use my algebraic process. To find P. So P equals 5. So now that I know that P is equal to 5, I could technically plug 5 into each of these and find out what those angle values are. So by doing so, I would find out that this is equal to 32, which means that this would be also equal to 32. Okay? So now what if I wanted to find the other two missing angles? Well, what do I know about conservative angles? Well, I know that I could add those two together and they have to equal to 180 degrees. So A plus B, 180, A is 32. So thus B is equal to 148, which is an opposite angle to angle D. So then D is also equal to 148. And so by doing this, I have found the angle measures of all my missing angles of my parallelogram. So in this instance, the only difference is that you first want to find P, and by finding P, once you find P, you plug it in, you get the actual value or the actual measure of that missing angle. So any questions about this? About how I found P or why I plugged P in? Okay, we're almost done. So there is another theorem we're going to look at. This is the parallelogram side theorem, which basically says opposite sides of a parallelogram are congruent. So instead of opposite angles, opposite sides are congruent. So what does that mean? Well, let's say we're looking at this side. Opposite sides are those on the opposite side. So my opposite side would be this one. And because they're congruent, if I knew that this side was equal to 8 inches, well, then this side would also be equal to 8 inches. Same thing if for this side, well, its opposite side would be the side opposite. So this side. And what does that mean? Well, that means if I know that this side's 10 inches, well, then this side would also be 10 inches. So that is my parallelogram side theorem. Opposite sides are congruent. Okay? So what does that mean? What kind of problems can I solve when I use that? Well, I can find what is the missing side length, or what is the length of side MN of parallelogram LMNO. Well, what's MN? This one. And what do I know about MM? Well, I'm given an equation for it, but I'm not necessarily given an actual value. Well, what do I know? I know that its opposite side is congruent. And because its opposite sides are congruent, I can put those equal to each other. Solve for x. This is a subtraction. Okay. So 5x plus 18, 8x minus 5x, 18 equals 3x. Isolate x further. x is equal to 6. Now that I know that x is equal to 6, I can plug in x. So I get 5, 6 plus 1, 30 plus 1, 31. So that means my missing side length mn is equal to 31. But what else did that tell me? Well, that my opposite side would be congruent. So my LO would also be equal to 31. Okay, so that's how we can use the parallelogram side theorem to solve problems where we're asking to find the measure or the length of the missing side. Okay, then the last theorem we're going to look at is the parallelogram diagonal theorem. This basically says the diagonal of a parallelogram are bisects of each other. So what do we know about bisects? Well, we learned that bisects cut side lengths into two congruent halves. Right? We've looked at these before. And so what does that mean? Well, that means that our diagonals bisect, creating two congruent halves. So for example, if I knew that this entire side length, or this entire diagonal, B to D was equal to 22 units, and if I knew that the diagonal bisected it and cut it in half, well, then what I can get from that is that B to E would be equal to 11, and E to D would be equal to 11, because those are two congruent halves. 11 plus 11, the same angle measure, but 11 plus 11 equal 22, which was the measure of my original side length. Okay. Any questions about this before I do an example? Questions, concerns? Okay, so an example. So this one's asking us to find the measure of side length, PR. So the entirety of the side length. Well, what do I know about these two halves? Well, I know that those two halves must be equal to each other because the diagonal, this diagonal right here, cuts them into two congruent halves. So that would tell me that PT is equal to or congruent to TR, which means that I can plug in the different equations I have, solve for y, and then plug it back in. So right now I'm looking for y. So 15 equals 3y, further isolate it. So y is equal to 5. Okay, now that I know is y is equal to 5, I can plug it into these equations and solve for my halves. And when I do that, I find that they're equal to 64. But I'm looking for the entire length of PR. Okay, well, the entire length of PR would be me adding those two together. So PR is equal to PT plus TR, which is 64 plus 64, which gives me 128. Okay. Does anyone have any questions on how I found PT or TR, or how I found the entire length of PR? Any questions? Or why I got y equals 5? Okay. So what did we go over today? Well, we went over different types of parallelogram angle theorems and side length theorems. So let me go ahead and divide these. So these are the theorems that we will use to find missing side lengths, or missing angle measures, angle measures. And these are the ones we will use to find missing side lengths. Right? And so the parallelogram angle theorem basically told us that opposite angles are congruent. The supplementary conservative angle theorem told us that conservative angles that share a same side, remember, are supplementary, so they equal 180 degrees. Parallelogram side theorem told us that opposite sides are congruent, so they're equal to each other. And the parallelogram diagonal theorem told us that diagonals bisect each other, bisect meaning they create two congruent halves. Okay. So does anyone have any questions about any of the different terms that I've highlighted here? Opposite angles, congruent, conservative angles, supplementary, or opposite sides, or bisect? I think the only new one that we're looking at today would be conservative angles. And then once again, just for clarification, conservative angles are angles that share the same side. So if I had a parallelogram like this, then these two would share the same side. These two would share the same side. Also, these two could share the same side. Oops. And these two. So they're just angles that share the same sides depending on whatever side you're looking at. Okay? So any questions about anything we learned today? Okay. So we'll go over some practice problems tomorrow, but if there's no other questions, you guys may log off and I'll see you guys tomorrow. Bye, guys.